Hello, my name is Jocelyn Doucet. I'm the founder and CEO of Pyrowave. Thanks for the opportunity to present our wonderful technology to the Circular Chemistry Conference. It is such an honor to be here with other great speakers. Pyrowave is a pioneer in process electrification and circular economy of plastics. Our main application is a system that converts polystyrene back into high-purity styrene monomer. This conversion is achieved entirely using electricity and a new generation of proprietary microwave technologies covered by more than 30 patents. The production of basic commodities like steel, cement, and plastic represents the top 3 largest greenhouse gas emitters. This is mainly because most of these commodities are produced by processes that run on thermal energy. In parallel, lots of progresses were made in the renewable energy sector in the past 30 years. Costs for renewables decreased sharply and now becoming cheaper than conventional carbon-intensive energy sources. It is therefore a subject of interest to see how we can use renewable electricity for production of commodities. Electrification of commodities requires new sets of technologies that can use renewable energy as a primary source of energy. It is also an opportunity to see how we can better use these energy sources to unlock additional benefits. In the present days, we see a lot of companies proposing aggressive plans to electrify their processes. We see things like electrifying cracker, steam reforming, drying, evaporation, and distillation. While it may sound like a good start, I think that's not enough, and I believe we can do more on how we can use electricity to unlock the whole potential of electricity in commodity production. Lately, many companies approach electrification by switching fuel heaters to electrical heaters. This is an easy way to use electricity without changing too much the process. This approach is a little bit like turning a steam train powered by a coal boiler to a steam train powered by an electrical boiler. It will certainly have less emissions, but any modern eye will see that doing that is not wise. It certainly works at moving the train, but at least 2/3 of the electrical energy will be wasted as heat instead of moving the train. However, it surely is the solution that minimizes changes on the train. And by doing that, we miss a whole opportunity to revise how the train is put in motion. As such, retrofitting an electrical heater on a steam train will not make the train go faster because it relies on the same principles and suffers from the same limitations of using steam to turn the wheels. Our approach is to leverage all the potential of electricity by developing new technologies that not only turn the process electrical, but also enables new possibilities. In the train analogy, developing electrical motors and electronics enabled the new generation of high-speed trains. These trains are not only low emissions, but they can go a lot faster than steam engines because they rely on a completely new principle for turning the wheels. This is what we do at Pyrowave, developing new technologies using electricity to enable new opportunities for commodity production. Our breakthrough is our modular platform using microwaves as a vector for chemical reactions. This platform is successfully applied to circular economy of plastics. Our reactor converts plastic waste into high-quality monomers that can replace virgin feedstock in the production of new goods. Our innovation is now globally recognized and gaining traction in the scientific community as we published several papers explaining the disruptive nature of microwaves. A recent paper was featured in the Circular Economy of Polymers, published by the ACS, now a bestsellers after only a few months. I'm glad to be here today introducing our microwave technology and discuss our next steps in Europe. What we do at Pyrowave is the exact opposite of what the polymer industry did for the past 50 years. Polymers are assemblies of monomers attached together. Think of little Lego bricks that are snapped together to form larger assemblies. The bricks are monomers and the assemblies are polymers. So basically, for more than 50 years, the industry focused on assembling these little monomer bricks. Nowadays, our primary interest is disassembling these bricks perfectly without damaging them too much. Thermal degradation of polymers is one way of breaking down the polymers into monomers. However, several technologies will have various disassembling accuracy, and the process may break apart some bricks into smaller elements. The process will produce monomer of interest, the smaller molecules that are still big enough to form liquid, smaller molecules that form non-condensable gas, some bigger molecules that did not break during the reaction, and finally some more molecules produced through recombination of smaller molecules together. Different technologies will produce more or less of the various components. The principal advantage of the microwave technology is that we're able to maximize the production of monomer over other compounds. The key for achieving high selectivity of monomer is being able to have a gentle and selective unsnapping process that disconnects the bricks without breaking them. It's what microwave do, and I will explain you how. Everybody who uses a microwave at home knows that plastic alone don't heat. In fact, only the material inside the container will interact and heat under the action of microwaves. To initiate depolymerization with microwaves, we use a specifically designed support that delivers the electrical energy to the reaction. This support must be adequately chosen to convert the electrical field into hot spots to support the reaction. To start with, the support is immersed into the molten polymer mixture where both the support and the polymer have the same temperature. Once the microwave field is applied, only the support will heat while the polymer will remain at lower temperature. Then, when the polymer chain touches the support, the first brick touching the support will be chopped off instantly. This is called a chain-end scission mechanism. This mechanism is gentle and favors production of monomer. When we look at conventional pyrolysis processes, the heat is normally transferred by a surface heated by a media on the other side. When the heat source is powered on, the surface temperature increases and the heat flows into the polymer melt. The molecules then increase in temperature, and vibration of the chain causes the chain to break. Because the whole polymer chain is at high temperature, the monomer bricks are still undergoing further degradation, causing the bricks to break into smaller bricks. This has the effect of reducing the net production of monomer bricks. The mechanism involved in this case is called random scission, meaning that the chain breaks randomly along the chain into various components. Some could ask why nobody did it before. Other people did study microwaves and chemical reactions in the past 50 years. However, most of those works were at lab scale. The difficulty until now was the ability to scale the process at industrial level. Our unique patents and know-how cover new generation of high-power microwave reactor devices. The result is not only a plastic recycling technology, but a very powerful platform that can be used to produce a variety of chemical using microwave energy. At Pyrowave, we have a proprietary technology, so we can operate through licensing and as original equipment manufacturer. This means we are selling the equipment modules comprising the proprietary reactor, alongside with the process book that basically gives the recipe on how to operate and integrate the technology. This is possible only because we have a true proprietary technology. Our initial focus is working with other change makers with strong sustainability targets who want traceable drop-in replacement solutions for their virgin commodities. We primarily focus on companies consuming styrene for production of styrenics like GPPS, ABS, SBR, and EPS. We are currently signing pre-licensing agreements with potential clients all over the world. These agreements provide access to licensing terms as well as the industrial level engineering package that has been developed jointly with Pyrowave and our partner Michelin. One of the key components for circular economy is understanding the value chain. While mechanical recycling has been around for more than 50 years, only 10% of the incoming plastic can be returned into virgin-like applications. While mechanical recycling techniques may not be good enough to return all the plastics into virgin applications, they are certainly good enough to make them ready for further treatment like chemical recycling. Mechanical sorting of plastics is a bit like refining crude oil. In a refinery, crude oil is separated to extract valuable products. Some products like fuels can be used as is because they meet market quality, with only one separation step. Other products like heavy residues require additional separation to extract the remaining material. After this additional separation step, the various products have a quality acceptable for downstream chemical processing and eventually become plastics and chemicals. By analogy, plastic bales are separated mechanically in a plastic recycling plant to extract valuable product like polymers with market value as is. However, the heavy residues can be reprocessed through more advanced sorting equipment to extract the remaining polymers. However, these will have lower quality, unacceptable for market use, but acceptable for downstream chemical processing. So for me, mechanical recycling is like a refining step in a petrochemical plant. It is certainly needed to maintain quality. It is still the best way to prepare the feedstock to match quality input of most chemical recycling technologies and extract the maximum value from incoming feedstock. Pyrowave is increasing its presence in Europe for circular economy of plastics. We are starting our commercial activities in Europe with Michelin being our first client. In November 2020, Pyrowave and Michelin announced a joint development project for industrialization of the Pyrowave technology and established new value chains in the circular economy of plastics. Michelin has strong ambitions to turn 100% sustainable by 2050, and as such, sourcing renewable styrene monomer for the production of synthetic elastomer is strategic. With our technology, Michelin will be able to produce renewable styrene from polystyrene waste and integrate renewable content into their synthetic elastomers. Since the successful collaboration started, Pyrowave joined Chemical Recycling Europe, Michelin joined the Polystyrene Recycling PS25 Consortium. The engineering of the project is now complete, and we have been signing pre-licensing agreements with clients all over the world. We are looking for additional clients looking for renewable styrene solution with our innovative proprietary technology. In summary, we have exposed the Pyrowave technology platform, showing unique performance over other types of technologies, in particular in terms of yields, selectivity, and environmental impacts. We have been 10 years in the making, and now starting the commercial deployment with a first flagship project in Europe that will hit production in 2024. We are now actively looking for new clients for licensing of our technology, companies with styrene consumption applications, and high-value performance products with a strong environmental and sustainability focus. Electrical solutions are urgently needed to address the low-carbon requirement of commodities and meet our greenhouse gas reduction targets. In addition, the plastic waste crisis is becoming a growing pollution problem. New solutions to deal with end-of-life of polymers have been developed, and we believe that our unique proprietary electrical chemical recycling technology offers the best performance while enabling a new world of possibilities. I hope this presentation could better explain how our technology truly differentiates from others. I hope you could see the value of using microwave technology to make a difference. Thank you.